Good day, everyone. Our topic for this time is trigonometric substitutions. This is still part of the techniques of integration. The two parts we already discussed, the integration by parts and the algebraic substitutions. Now, in this topic, we will consider the three conditions. First, if the integrand involves a squared minus u squared, we use u equals a sine theta. And if it is, or if it has a squared plus u squared, then we use u equals a tan theta. Then also, if the integrand involves u squared minus a squared, then we will use u equals a secant theta. Now, let us consider the first example, integral of x squared dx all over the square root of 9 minus x squared. As you can see, the denominator involves or has 9 minus x squared, which is same with the form of condition 1. A squared minus u squared. Meaning, a squared is equal to 9, u squared is equal to x squared. Therefore, a is 3, u is x. Now, since it is under condition 1, we will use the equation u equals a sine theta, which is equal to 3, x equals, our a is 3 sine theta. Then differentiating, we have dx equals 3 cosine theta d theta. So since we already have the values of dx and x, we can now substitute to the given integral. X squared, x is 3 sine theta, so quantity squared, dx is 3 cosine theta d theta, all over the square root of 9 minus x squared. X is equal to 3 sine theta, therefore it is quantity squared. Then by simplifying, we have 9 sine theta times 3 cosine theta d theta all over the square root of 9 minus 3 squared, 9, then sine theta squared is sine squared theta. Also, we have 27 this is sine squared theta cosine theta d theta all over 9 is common, so we can factor out 9, then multiply by 1 minus sine squared theta. As you can see, the denominator can be simplified using the identity for 1 minus sine squared theta, which is equal to cosine squared theta. Then upon getting the square root of the denominator, we have 27 sine squared theta cosine theta d theta all over 3 cosine theta, which can be simplified by 9 integral of sine squared theta d theta, since we divide 27 by 3 and cosine theta by cosine theta. Then getting the integral of sine squared theta d theta, this is trigonometric transformation, wherein we can, or we will use the corresponding identity of sine squared theta, which is equal to 1/2 1 minus cosine 2 theta d theta. And therefore, we have 9/2 times the integral of 1 d theta minus cosine 2 theta d theta, and can be evaluated by theta minus 1/2 integral of cosine 2 theta 2 d theta. Since u is 2 theta, therefore du is 2 d theta. And the balancing factor is 1/2. So we have 9/2 multiplied by theta minus 1/2 multiplied by the integral of cosine 2 theta, which is sine 2 theta, plus c. Then further simplifying of 1/2 sine 2 theta, we have sine theta cosine theta plus c. Remember, the identity of 1/2 sine 2 theta is sine theta cosine theta. Therefore, we have 9/2 theta minus 9/2 sine theta cosine theta plus c. Now, this is not the final answer, since we just use trigonometric to evaluate the integral. So meaning we need to find the values of theta, sine theta, and cosine theta in terms of x, or in algebraic form. So how do we do that? Since we use the substitution x equals 3 sine theta, therefore we can obtain the value of sine theta, which is equal to x over 3. Now, to find theta, theta equals to the arc sine theta, or arc sine x over 3. How about the value of cosine theta? Now, using right triangle, we all know that the function sine theta is equal to the opposite side over the hypotenuse. In this case, the opposite side is x. So meaning, if this is the acute angle, the opposite is x and the hypotenuse is 3. Now, solving for the adjacent side, we will get the square root of 3, which is 9, or sorry, the square of 3, which is 9, and the square of x, which is x squared. This is this can be solved now using Pythagorean theorem, solving for the other side of the uh, right triangle. So the value of cosine theta based from the right triangle is equal to the adjacent side over the hypotenuse. Substituting those values of theta, sine theta, and cosine theta, we have 9 over 2 times arc sine x over 3 minus 9 over 2 sine theta is x over 3 and cosine theta is square root of 9 minus x squared all over 3 plus c. Then upon simplifying, we have 9 over 2 arc sine x over 3 minus x over 2 times the square root of 9 minus x squared plus c. So the final answer now is in algebraic form or in terms of x. And this is done by trigonometric substitution.